Alright, this is part 3 of our review of working with polynomials. In this video we will focus on division of polynomials. We'll do long division and synthetic division. Alright, long division. For starters, you have to understand the order. If I have, let's say, 200 and I want to divide that by 3. Then of course when I set up my long division, I put the 3 out here and I put the 200 in here. Okay, the thing that you're dividing by goes in the front. The thing that you're dividing goes underneath. So I had at least one student, maybe more, terribly confused about which thing to put in front. So hopefully based on that little example, you can see that we're dividing by this trinomial. So the trinomial needs to go in the front. So I need to have my x squared minus 3x plus 9, okay, in the front. And this is going to be divided by x to the third power plus 27. Now, this was bothering some students because this one seems so long and this one seems so small, and normally don't you want the smaller one out here? But you're looking at the wrong thing if that's what you were thinking about, because you need to be looking at the degree. Alright, we're dividing the larger degree polynomial by the smaller degree polynomial. So it will help you see what's going on if you go ahead and include all the missing terms that we have. So this goes straight from the degree 3 all the way to degree 0. So we're missing the second degree, alright, which I will write as 0x squared. And we're missing the linear term, which I will write as 0x. We're missing two terms. So go ahead and write them in to hold those places. And then we'll put our plus 27. Okay, now we can begin the process. Now focus on the first term of each polynomial. And you should ask yourself, x squared times what will make x to the third power? And hopefully you immediately think x. X squared times x would make x to the third power. Okay, so that's what goes up here. X squared times x will make x to the third power. Now I like to line up my like terms, so I'll put my x right here. Not super important, but it helps you know when you're done. Alright, now once you've done that, then you need to take this and do a distributive property with it. Okay, so I'm going to take this x and I'm going to do the distributive property like this. Okay, so x times x squared, that's x to the third power. X times negative 3x is negative 3x squared. X times 9 is 9x. Okay, now when you do long division, once you get this, you always subtract this. And for polynomials, I like to subtract by simply changing the signs and combining like terms. So I'll make this negative, I'll turn this positive, this needs to be negative. Okay, so if I combine like terms now, then I'm really subtracting. So these will cancel each other out, always. But 0x squared plus 3x squared is 3x squared. 0x minus 9x is a negative 9x. And then we'll just bring down our positive 27. So at this point we basically start over again. Okay, so once again we focus on the first term of each polynomial. And once again we ask ourselves, x squared times what will make 3x squared? Well, that's pretty obvious. We need a 3. X squared times 3 will make 3x squared. So once you have that, you do the distributive property with it. So I'm going to take this 3 and I'm going to distribute like bam. What? I said Kabam. So that's what you're going to do. So if I do 3 times x squared, I get 3x squared. 3 times negative 3x is negative 9x. And 3 times 9 is 27. Alright, now it won't always come out like this. Sometimes there's a remainder, but in this case, once I subtract by changing the signs, okay, all of these cancel out. So that means this divides in evenly. I get a remainder of 0. So that means what I have right there, that x plus 3, that's going to be the final answer. Okay, so that's it. I'm just going to mention as just an extra bonus, when something divides in evenly like this, what we really have done is we have also just factored, okay? Because if I take the divisor and the quotient, you know, the answer that I got, if I multiply those together, that should get me back to where I started. Okay, so in other words, please understand, what color do I want to use? Please understand that x plus 3 times x squared minus 3x plus 9 alright, must equal x to the third power plus 27. Okay, so this division is another way of factoring, alright, because we just took x to the third power plus 27 and we now have factored it as x plus 3 times x squared minus 3x plus 9. You might notice that this is the sum of two cubes that we talked about in a previous video. So we could have gotten this by factoring the sum of two cubes, and it would look like this, just like we practiced. Alright, anyway, that is it for the long division. So let's go ahead and take a look at number 8 for some synthetic division. Okay, synthetic division works like this. Start by making a box. Okay, now look at the coefficients. 3, negative 11, negative 6, and 8. Okay, skip a line and draw a line and put another box here at the end. Now whatever ends up in this box is going to be the remainder. Okay, so next, what goes in the box here? Well, I've got x minus 4, so this is going to wind up being a positive 4 here. What's really happening is we're imagining that x minus 4 is a factor. Okay, and so if we set this equal to 0 to find potential zeros, it's really what you would get if you solved this. So if adding 4 to both sides, that would give us x equals 4. That's why we're putting a 4 in the box there. So you might think, oh, it's the opposite. Just why don't you just say that? But the reason is, what if it had been like 2x plus 3? All right, what goes in the box now? Well, based on what I just told you, if you set this equal to 0, so I'd have 2x equals negative 3, divide by 2, so that'll be x is equal to negative 3 over 2. Guess what? Negative 3 over 2 is what we would put in the box. Alright, but that is a question for another day. Alright, so to continue the process, the first thing you do is just bring down that first number. After that, you multiply by the number in the box and you put it in the next available space. So 3 times 4 is 12. And you combine like terms. So this is going to make 1. Alright, and you repeat. 1 times 4 is 4. Together, that's negative 2. And again, negative 2 times 4 is negative 8. And okay, once again we have remainder 0. That will not always happen. Sometimes we have a remainder, but this time we don't. So these remaining numbers here are coefficients. So we need to put the variables back in. So if I put the variables back in, considering this is the remainder now, so set that aside. That means this third number is the constant. You know, like this 8 is a constant. This -2 is a constant. So if I go over one more term to the left, that means this is the linear term, and this is the quadratic term. Okay, so let's rewrite this as a normal trinomial, like you do. So this makes 3x squared plus x minus 2. So this is the result that you get. Now, let me mention one more time, since we had no remainder, that means this divided evenly into this polynomial. So that means we have factored once again. So let me just squeeze this in here. That means if I were to multiply, the thing I divided by, so if I did x minus 4 times this trinomial that we just got, that should get us back to the original problem. X to the third power minus 11x squared minus 6x plus 8. So basically we just took this polynomial and through division we factored it as this times this. Alright, so probably if we did grouping, maybe we'd come up with this. I'm not sure about that. No, grouping wouldn't work. Okay, grouping wouldn't work. So, but by division, we were able to factor something that up until now we wouldn't have known how to factor. But that's where we're headed in future lessons. So I was just giving you a glimpse into the future of polynomials. All right, let's squeeze one more division problem into this video. Okay, so one more time I want to use synthetic division. So there's my box, and my coefficients are 1 and 2 and 9. Okay, that'll be for my remainder. And inside the box I will have -3. Alright, from that, from setting that equal to 0 and solving, that's -3. Now, the first number, you just bring it down. So 1 times -3 is -3. Add these together, and you get -1. -1 times -3 is +3. Add these together, and you get 12. Okay, this 12 is the remainder. Okay, that makes this the constant, and that makes this the linear term. Okay, so in other words, what we have here is simply x minus 1. So this, well, I have to include the remainder. So we have x minus 1. I think I'll put it over here. So we have x minus 1. Okay, now the remainder gets added on the end in as a fraction. So I have 12 over the thing we divided by. So 12 over x plus 3. So this is the answer for number 9. Okay, so that's going to be the end of this video. Alright, in part 4 we will pick up from here in the next video, and we'll talk about some of the terminology surrounding polynomials. Okay, standard form, degree, leading coefficient, constant will classify things like cubic, trinomial, quadratic, binomial, stuff like that. So that's what we'll do in the next video. And if we have time, we might go ahead and add subtract and maybe multiply. We'll see how much we can get into a video. See you on that next video, guys.